Okay, guys, so in this video, I'm going to be discussing the distance between 2 points using the Pythagorean Theorem. And this TEK is 8.7D. So we can find the Pythagorean Theorem formula on our reference chart here. And we're going to go ahead and jump into the first problem. It says, point R has coordinates at -1, -7. So I'm going to go ahead and plot that point here. And then it says point S has coordinates as 6, 4. So I'm going to plot that point here. Now it says, what is the distance between point R and S? Now, like I said, we're going to be using the Pythagorean theorem. And the reason that we're going to be using that is because in order to find this distance here, I am going to have to create a right triangle using the 2 points that were given to me. So you can either create your right triangle going this way, like that's your 90-degree angle, or you can create your right triangle or your right angle going this way. But try and make it as straight as you can. Don't mess up like I did. So, but I want to do it down here. So I'm going to go straight across, and then I'm going to come straight down to meet at a 90-degree angle. So here, remember that from your 90-degree angle, that is always going to be your side C. So because I have a right triangle, I'm going to use the formula a squared plus b squared equals c squared. Now, I know that I'm going to be looking for my C because that's my diagonal. That is the distance between point R and point S. But now I have to actually find how much each one of my other sides is. I'm going to go ahead and do my A for this one and my B for this one, just because of that small, medium, and large that I told you guys about. This is the small side, this is the small side, this is the medium side, and C is always going to be our largest side. So now let me go ahead and count. I'm going to count each one of these little boxes here. That's 1, 2, 3, 4, 5, 6, 7. So this side measures 7. This side over here measures 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So now using those numbers, I'm going to go ahead and I'm going to plug them in over here. So 7 squared plus 11 squared equals C squared. I'm going to go ahead and I'm going to do it the long way. 7 times 7 is 49 plus 121, because that's what 11 times 11 is, equals C squared. I'm going to add these two numbers up, which is 170, which equals C squared. But remember that you're just looking for C. You're looking for that distance between points R and S. So just like we discussed before, in order to find just the letter C, when it's squared, we take the square root from both sides. These two are going to cancel out, leaving me with just C. Now, if you didn't have a calculator, this would be perfectly acceptable, the square root of 170. But because we do have a calculator, we're going to go ahead and we're going to simplify that square root of 170. So let me go over here. I'm going to use my Desmos calculator. Square root. Bring this down. Of 170. That gives me 13.03840481. But I only want 2 decimal places. So I'm going to look at just this portion right here with the 2 decimal places. So that was 13.03840481. 13.038. Because of that 8, the 3 is going to round up. 13.04. That is what the distance between point R and S is. It's going to be 13.04. Now, like we discussed, we can also double check ourselves by going to our calculator and plugging this into N-Solve. So we're going to keep that. Go to our calculator. Go to calculate. We're going to go to menu 3.1 for our N-Solve. And we're plugging in 7 squared plus 11 squared sorry, it's messing up on me a little bit. Okay, equals our C squared. And we got to tell the calculator that we're looking for C. And we can see that we have the same exact answer that we just got. But remember to round. Let's look at one more example. Okay, in this example, they already went ahead and they plotted the points for us. So it says Lucy walked from her home to the post office, then to the bank as shown. So she went from her house to the post office, then to the bank. It says the post office is 5 miles from Lucy's home. So here I can see I have 1, 2, 3, 4, 5 units, and they're counting it as miles. So that's the units that we're going to use. And then it says, what is the shortest distance Lucy can walk to return home? So the shortest distance is going to be this diagonal right here. Imagine she can cut through grocery stores and people's houses, people's yards. She's not going to get in trouble or anything like that. But she's going to cut straight through here. So here I see that I have a perfect 90-degree angle. And I know that that's my side C. I already have what this side measures, and I'm going to label that as A. This side from the post office to the bank, I'm going to label that B. And now all I have to do is actually count to see how many spaces I'm using. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm using 12 units here. So we're going to use the same formula because this is a right triangle. We're going to use the formula A squared plus B squared equals C squared. A is equal to 5 squared plus 12 squared equals C squared. 5 times 5 is 25. 12 times 12 is 144. And that is equal to C squared. So I'm going to add these two numbers up. That gives me 169 equals C squared. But as I can see here, I don't know why that doesn't want to do squared. Okay. But you guys get the point. That's a squared right there. I need to take the square root here. And when I take the square root, this and this cancel out, leaving me with just C by itself. So the answer could be the square root of 169. But I don't see that in my answer choices down here. So that means that they went ahead and they simplified this in their calculator. And when I take the square root of 169, let's find that. The square root of 169. Oops. That gives me 13 as my answer. So C is equal to 13. My answer here would be B. And like I said, you can always go back in and double check yourselves by taking this portion and putting that into N-Solve. So let's go there. We're going to go menu 3-1 for our numerical solve. 5 squared plus 12 squared equals c squared, comma c, so that we know that we're looking for the letter C, and gives me the same exact answer. And that is how we use the Pythagorean theorem to find the distance between 2 points on a graph.